we don't have application system.
So it's a pleasure for me to be here at the data science class. Professor Longo is always too kind with me, so thank you for your kind words. There are a number of reasons why I'm really happy to be here. The very first reason is related to the name of this lecture. This is a Picariello lecture. And I don't know if you know, but if you know Professor Longo, perhaps you've been already listening to some of his dedications to Professor Picariello, but mine is one more such dedication. Antonio was one of my best friends, at least at the professional level. He was a colleague of mine. We've been working side by side for a number of years. We shared almost the same spaces. We were at the same department, and our offices are side by side. I think that Antonio was one very nice person, and he was a great professor. And this lecture is in his memory, and I hope I will give my best, and I will honor his memory, really. So this said, before getting started, I would like to know really a bit about your background. I mean, I'm going to talk about security, okay? Do you have any ideas of what cybersecurity is all about and what the terms that you find here, especially offensive security, is all about? Okay, no worries. Obviously, we are going to talk about security. Securing a system means making the system more robust, okay? When we use this term typically as engineers, because I am an engineer, I'm not a scientist, as you are going to be, we try to somehow use this term by projecting it along a few directions, okay? We typically talk about what is the CIA triad. C stands for confidentiality, I stands for integrity, A stands for availability, okay? So basically, we try and provide these properties to systems. And we are talking about networked systems, so we are working with the internet, okay? So as part of my professional life and also as part of my life as an educator, I teach security, and I use an approach that is an offensive one, okay? An offensive one means that I try and put myself in the shoes of an attacker, and I try and understand the behavior of an attacker, okay? And I always tell my students that if you do this in an ethical way, you become a very good professional. Because if you want to learn how attackers act in their lives, you must be better than them at attacking systems, okay? So that's why we typically talk about offensive security or even offensive defense, okay? As part of this approach, when we study the properties of systems and we try and understand what might be their vulnerabilities, we, as I was telling you, put ourselves in the shoes of an attacker and we try and investigate the system as if it were a target for us, okay? This activity is called typically vulnerability assessment / penetration testing, okay? Penetration testing is like, you know, trying to get access to a system without causing any harm, okay? So you look at the system, you look for vulnerabilities, and if you find a vulnerability, you typically provide either your customers or yourself, if you're working on your own systems, you provide what is called a proof of concept, a POC, that demonstrates that that vulnerability might be leveraged, exploited in some way, okay? When doing this, typically you use your fantasy, and as creative as you can be, this will change the way you succeed when working in this professional arena. And obviously, there are things that are done in a human-driven way, and there are things that we try and implement in an automated fashion. The ideal scenario is one in which we can reproduce automatically the behavior of an expert human being, okay? So ideally, I would like to find solutions, and this is part of my research. I would like to find solutions whereby I can let a software system do my job, okay? But when I say do my job, I mean my job. So the job of someone who believes to be, who claims to be an expert security guy, okay? I will try and highlight a few of the features of the systems that we study. And since I was giving for granted that this class is not composed of people who have background in cybersecurity, first off, please stop me in case there is something that you do not understand. Just raise your hands and ask questions. And secondly, I will try and also provide you with a very brief introduction, also with a practical approach, okay? In much the same way as other people currently do, Professor Longo is one such professors. I use a learn by example approach quite extensively, which means that I try and let my students experiment with things, okay? So they put their hands on the real thing. And I will try and highlight also this. So the title of the talk is exactly around the lines that I was introducing. It's automated offensive security. And the second part states that if you are capable of being smart with that, perhaps you can find solutions that have a higher performance when compared to state of the art, okay? It is important to notice here that there are credits to Francesco Caturano, who has been one of my best PhD students. He is now working for a cybersecurity company, obviously, in Spain. And by the way, he's working on very tough things. He's working on finding what is typically called a zero-day attack. So an exploit, an attack that did not exist until yesterday, okay? But he's doing this with a white hat on his head. Typically, we talk about black hat hackers. These are the bad guys. And we talk about white hat hackers. And these are the good guys. So all of my students, 100% of them become white hat hackers, obviously. There would be no need for adding these further specification to the term hacker, just because hacker in itself is a very nice term. It means that you like to experiment with things, you like to put your hands on the real thing. But nowadays, we must definitely further specify the term just because of the fact that media have typically claimed that hacking is a bad thing and that hacker is a synonym for attacker, which is not the truth, okay? So now let's move to the introductory part. Just hold on 1 second. Okay. So the context is first about introducing the idea of offensive security. Then we will quickly move to a sort of specialization of such an idea that is penetration testing. And in particular, penetration testing associated with the study of web applications, okay? I will try and provide you with a bit of context related to that, also by pointing to one of the most important projects that we use as a reference for all this. And then we will move to the study of a few tools that can be used in order to make penetration testing as automated as possible. I will highlight a few contributions from my research group that are exactly in this field, okay? But as I was telling you, I won't go into any, I hope, boring detail. I will stay at a very high level. We will scratch the surface. And this, for me, is important in order to trigger something in your minds to stimulate your curiosity, okay? So if I succeed with this, we will see at the end, I'm very happy. What are web application vulnerabilities, okay? We all use the web. We are all used to leverage our preferred application that is a web browser. And typically, 90% of things that we do nowadays are carried out via a browser, okay? Even a Teams call can be carried out just by launching one's own browser and using it in order to access a complicated application that is an integrated multimedia environment. There are people who dedicate a lot of time to the study of vulnerabilities of web applications. First off, what is a vulnerability? What do you think that a vulnerability is all about?
A valid credential. I mean, if I'm not authenticated user, still I want to enter to the code or enter to the program.
Okay, I will repeat for the remote users. One of the students here has stated an interesting sentence that is, vulnerability is when I try and access a system even though I have no right credentials for doing that. I have to say that you took too many steps ahead. Okay, you were already thinking of something that we call an attack. Okay, so it's okay, but it's not as sharp as it should be in terms of defining the clear context of that term. A vulnerability is just that, a vulnerability, a defect, okay? A fault of a system, in my case. What is a defect? It's something that does not work properly, okay? Just that, okay? What your colleague was mentioning is something different. He was thinking of another concept that is an attack. What is an attack? An attack is a sequence of steps that I can follow if I want to exploit a vulnerability. Okay, so an attack is a way for exploiting a vulnerability. Ideally, if there were no vulnerabilities, there would be no means for attacking systems. Okay, right? But in the presence of both vulnerabilities and attacks, we might be okay. Why? Because there's a need for the third entity that is the most important one, perhaps, that is a threat. What is a threat? Una minaccia. Is someone, typically a human being in this case, or a human beings organization, who is interested in exploiting a vulnerability. So if the vulnerability is there, and if there is an attack for exploiting it, I must be worried if there is also a threat associated with that attack. Okay, so a threat is something that is there that might be willing to cause harm to me or to my systems. Okay, if my systems are vulnerable and if people have devised ways for leveraging those vulnerabilities in the presence of a threat, I'm done, I'm lost. Okay, so that's why if you had a look, for example, at our network here at Federico II, we're recording, so I won't go into the details, but we are definitely vulnerable here at the university, but in any organization, you will find vulnerabilities. You can give this for granted, okay? Typically, we are okay just because we are not under the radar of any threat, okay? But if we happen to fall under the radar of a threat, we're lost because we do have vulnerabilities. And there are attacks that allow people to leverage such vulnerabilities, okay? So there are people who study the presence of vulnerabilities, who try and come out with taxonomies that are used in order to classify them, okay? There's a project that is called OWASP. I invite you to point your browsers to owasp.org. That is a website that contains tons of documentation about web application vulnerabilities. And by the way, also data about how we might become smarter at protecting ourselves in the presence of vulnerabilities. There are tools, there are papers, and lots of interesting, let's say, pieces of bits and bytes about how we might start making our systems more robust. Okay, this is a very nice project. They come out typically with the top 10. The top 10 is just a ranking, okay? We can use also Ethernet. It should be with the USB-C, but it is attached here and it should arrive here. Let's keep as it is. Are you okay remotely again?
Oh, are you connected?
Yes.
Am I still sharing my screen? Yeah, okay. Sorry about the hiccup. So basically, as I was telling you, I won't go into the details. I will just make a very quick historical excursus of the top 10 between 2013 and last year, 2021. They typically come out with the top 10 each and every 4 years, okay? So we have 2013, 17, 21. And I'm just highlighting a few of the boxes here. The very first one that you see here is injection, okay? What does injection mean? Injection means injecting something into something else, okay? And basically, these vulnerabilities here are all associated with the fact that typically we interact with web servers in some cases by providing them with input, okay? If you have a web form, what you have is some text area, text box, menu field, where you can insert your own data, okay? And typically then you hit the submit button. When you hit that button, your data gets transferred to the web server, and web server will typically work on those data, okay? Obviously, if the server itself does not carefully look at the data that the user has provided, bad things might happen, okay? And this is what typically we mean when we say injection attacks. One of the most famous such attacks is called SQL injection. You all work with databases, okay? You've been definitely working with MySQL, Oracle, Postgres, or the like. You know that you have a language that is used for querying databases. And in some cases, when the application is what we call a three-tier application, we typically have a front end that is a web server that provides us with a view that we use in order to insert some data. Then we send such data to the server, and behind the scenes, the server itself interacts with the backend database, okay? If my input arrives at the backend database and it has not been properly sanitized, what might happen is that my input becomes part of a query, and that query is not managed in the proper way, and it can cause harm. This is one specific case. But injection is also the other box that I am highlighting. That is perhaps a bit more delicate if you want to understand it, and that's why I think I will try and provide you with a practical example. Ever heard about XSS, cross-site scripting? Cross-site scripting is typically what happens when there is some part of a scripting code. Typically, today it's JavaScript, that is the client-side code that can be executed directly from within our browsers, okay? If there is some code that has not been properly controlled that gets executed inside my browser, bad things might happen, okay? And this is one of the most well-known attack patterns, okay? And it is also one of the most widely deployed vulnerabilities nowadays. So I will skip the others basically, but I will just show to you that in 2017, injection stays at the top in the class, and that we have cross-site that is at the 7th position. So it is a bit less important, let's say, but it is still there. This ranking is typically produced by surveying cybersecurity professionals, okay? So really asking cybersecurity professionals about their own experience. What did you find out there, okay? What were the main vulnerabilities that you had to confront yourself with while doing your work, okay? And just to make it simple, in 2021, this is latest ranking, cross-site scripting and injection have been mixed up just because people have realized that basically they fall exactly in the same category, injecting something into something else, okay? So I will skip this in the interest of time, but let's do this. I will share for 1 second another screen. that is this one. So here I am inside the browser, okay? And I am running a vulnerable web application. This is a web application that is provided directly by the OWASP community, okay? So as I was telling you, you find lots of useful tools also provided by the OWASP community. This is a fully fledged web application that allows people to get acquainted with issues that might happen in the web, okay? So let's have a look at this. I think that you can all understand what happens. Let's figure out that I have this search field, okay? Here I put Simon. If I ask search, I see here results for Simon, okay? If I put Professor Longo, I find here results for Pepe Longo. So what do you see here? What has happened? There's a reflection. I'm sending a string and the string is bouncing back to me and I'm showing that string inside an HTML page. You see that? Everything that I type inside the text box goes to the server, but then the server uses my input in order to provide me with the right answer, because the web page that I'm receiving back is a dynamically built one. It's not a static HTML page. It contains a few parts that are static and other parts that are dynamically constructed, in part with the input that I was providing to the server itself, okay? So this is interesting for me as a professional if I am doing a penetration testing of a website. The first thing that I do is, okay, input is reflected, okay? I'm sending input, I'm getting back input. So what would happen if the web server were not checking my input, okay? Let's have a look at this. What if I put this code? Is this text? Yes. Is this allowed? Yes. This is script alert, ha ha ha, script. I'm sending this to the server. What has happened? I sent my text to the server. The text has been bounced back to me, and my browser has simply tried to show that text inside an HTML page. Now you are not JavaScript programmers, but you can understand this, okay? If I have inside JavaScript some code that tells me this is a script, alert, open an alert window and print down the things that are there, okay? This is a cross-site scripting vulnerability, because this means that if there is a malicious user that instructs a browser to send a string like this one to the web server, what will happen is that that browser will receive back exactly that code, and that code will be executed within the context of that browser. So now this might look stupid. Why should I ever do that? It's not me, it's you who will do that. I will send you a phishing email containing a link. Click here and search for professors on Docenti Unina-IT. Okay, I will send you an href, an hypertext. Okay, you will just see a nice text. You click on that, but what is behind that text is my string. And what arrives at your browser, if you click there, is exactly my code. What might I do better than this? As a computer security professional, I would stop here. Okay, if this were Professor Longo's website, I would write to Professor Longo by saying, look, Pepe, there's an issue, okay? You have a server that is vulnerable to cross-site scripting, and this is my POC, my proof of concept. He would click and he would just see an alert, okay? But if I can run an alert script, I can run any other script, okay? Do you want an example? Let's do like this. Sorry. let's do like this. Oh, sorry. I will share my entire desktop in this case because we need to move from one window to the other. Do you see this?
Not yet, Tom.
You're quite close. Okay, this was what I sent before. So let's forget about this. Let's see this thing here. Okay.
The screen is not shared remotely, Simon Pietro.
Who can interpret part of this at least? Let's start from this /form. What am I doing here? I'm closing a form. Why that? Because the page that I was showing to you contains a form. Okay, so let's see. First off, let's see the effect of all this. I will copy this. I will go here. What has happened? I've sent that string to the web server. You see that there's something new here that was not in the page. This feature requires account login. It's not true, it's me. Okay, I'm saying there's a script with a function that mimics the presence of an image. The image comes from here. Let's skip these details, okay? But basically here I'm putting a new form. You see here? This is an account stealing phishing attack, okay? So you were just in a page where you could insert a name and the server would look for that name. Okay, I instructed you to click on my link inside my, let's figure out a phishing email, okay? You click, what happens is that you send this string here to the server and the server bounces back to you this stuff, okay? This stuff says this feature requires account login. How many times does this happen to us? Tons of times. And in some cases, it is definitely needed, okay? If you want to search for something, and this is an advanced feature, the website might envisage the fact that you must insert your own credentials. Okay, but if the website is vulnerable to cross-site scripting, I can mimic that behavior. So in this case, if you click here and I put
please, Simon Pietro, you have to share the screen. It's not visible anymore.
This would send, okay? Obviously, the attacker would craft a URL that instructs the browser when I click submit to send the stolen credentials to his own collector, okay? So that's how your credentials get stolen from time to time. Exactly. This is a simple one. I might show much more advanced ones. I can craft a script that can also, behind the scenes, interact multiple times with the server. Just figure out that you want to do a money transfer, send some money to Professor Longo bank account, and that this activity requires that you confirm that operation. I can craft properly constructed code that sends the first request, receives back the request for confirmation, and without any user interaction, clicks on the request for confirmation, okay? Any good enough JavaScript programmer might do that. My students can do that. And you might do that with 20 hours of class, okay? So this was to give you an idea, but this is a simple thing. The important thing is that you realize that this is reflected cross-site scripting. Reflected because there's a bounce back. I go to a server and something gets back to me from that server, okay? And when this thing arrives at my browser is a software base. It can run code. And if the thing that it receives back contains code, it executes that code, okay? So basically, what do you think we should do in order to get protected from these kind of attacks. As end user, nothing. Okay, you can just disable completely JavaScript from your browser, which means today that your browser would not work. There are people who do that. Okay, we call this paranoid behavior. And no, you should not laugh. I mean, we must be as paranoid as possible. This is what I teach. Okay, even when we design stuff, we must be paranoid. But obviously, there's a limit to being paranoid because we want to carry on our own lives, and we know that our browsers must do something in a dynamic fashion.
They say that they cannot see the screen.
Sorry.
Sorry.
Well, you could always write some scripts in the server, check the queries, and try to understand if this attack must be complicated, so you end up with very complex taxonomies, or two-factor authenticator, which is the simple solution that everybody is.
Okay, just for the remotes, we might work on the server. We have to work on the server. There's no other option. And what we must do is exactly what you were mentioning. It's input sanification. Okay, we must properly clean the input that we receive by looking, for example, for strange characters. Why should the less than sign be inside that string? Okay, question marks, ampersands, and the like. We should properly polish the strings that we receive. And by the way, we can also sanitize our output. What if instead of putting the string that is bounced back directly inside the HTML context, what if I put it inside the div? Do you know what a div is? It is a means for writing something inside an HTML page without asking the browser to interpret, to parse that text, okay? So if I put something inside the div field, even if it is JavaScript code, it will just look as JavaScript code printed inside my page, okay? So this is an interesting thing to do. So it's input/output sanification, okay? And this is where we try and contribute when it comes to creating safe enough web applications, okay? So it's exactly there. And indeed, we can now, it's coming, I hope, yeah. Okay, this was an example, but there are other examples that we might do. Let's keep this for a while. There's a taxonomy, please.
Can you see the, yeah, it.
Okay, okay. There's a taxonomy about cross-site, please.
So I was wondering if it's possible for them, Poste Italiane, understand who is the attacker, maybe leveraging the fact that in the HTML page there is database in which the data are sent to. I don't know.
Okay, nice question. The question was about a case associated with Poste Italiane. It's a very well-known one. With a phishing, smishing attack that many people have received. If there is a means for Poste Italiane, or in any case, the target organization, to understand who is doing the attack, we always try and track back the attackers, but it's not as easy as you might imagine, because typically you find traces of the attack, obviously, because you find, in my case, it was the web server of the attacker where the credentials get collected, or you find typically databases or things like that that get populated, or in other cases, you find wallets, for example, Bitcoin wallets that get transferred money to. Obviously, if you are quick enough, you can at least stop that thing from happening, which means you call the postal police and you ask them to act on that IP address associated with that specific instance of the database collector or the web server and so on and so forth. But before you do that, the thing has happened for a number of other users. So you must be quick and react. And when you react, thing stops, even though in many cases, all of these attacks are dynamically deployed, which means that if you stop one instance, a new instance can be very quickly deployed on a different node at a different address. And so it's something like, chasing someone who is capable of escaping in a very quick and dynamic fashion. And besides that, typically, the nodes where bad stuff is deployed are deployed on top of hidden networks, okay? I think you have heard about the Tor network that is used in order to provide anonymization to users, and there are cloud-based infrastructures that are used just for that. So typically, they get closed when there are malicious activities that are discovered, but this does not guarantee to you that the fact simply stops, okay? And tracing back attacks is a headache because of the fact that it's not easy to assert that the specific IP address that you identified as the source of an attack is really the source of that attack because of IP spoofing. So it's really a mess, okay? And by the way, the attack you were mentioning was a defacing attack, which is even worse in some cases, because basically you are redirected towards a site that looks exactly like the site you wanted to use, but in the reality, it is a different one. So you put your credentials on your Facebook account, and basically the server you were interacting with was not Facebook. So your credentials get stolen in that way. And one of the things that you were mentioning that is multi-factor authentication, that is that people do not want to use. Basically, it would solve 99% of these issues, at least the authentication issues. And broken access control is top in the category, okay? If you use at least 2 factors for authenticating, we do this with Teams, for example. Now, people have complained about that, but I've been asking for that indeed, okay? It's important because people cannot simply steal your account, okay? They must really acknowledge the fact that they are willing to enter and they do not just know your credentials, but they also hold something else, okay? So just think of that. It's tedious in some cases, but it can save your life.
Ask you some.
Sure.
In cases, like for instance, double checking. But then it's a not task again of this browser. It's very dangerous.
It is always dangerous, even though do not task again on this browser means that really if they want to trick you, they must use your browser because they somehow store a signature of the user agent that you were using. Okay, so they're sure that if you use exactly the same user agent, so the end user program that has connected and for which you have saved that choice, they must be on your PC, which is not a totally difficult thing, because if they hack your PC, they must not be physically in front of your PC, okay? And it's quite easy to hack a remote PC, okay? So let's say countermeasures are exactly the ones you were thinking of. You should properly clean the input and also think of cleaning the output. And when it comes to specific features of the attacks, for example, stealing the cookie of a session, okay? Do you know what is a session cookie? Okay, a cookie is a string, a token that gets transferred back and forth between my browser and the server after the very first time that I connect to that server, okay? And do you have an idea of what session stealing is all about? Stealing. Okay, I should not, perhaps I should not show this thing, but I will. This is for Professor Longo, okay? Professor Longo, what site is this one? This is the life of a university professor, okay? The entire life of a university professor. So this is my account. First thing to notice, what's my username? It's part of my fiscal code, which is bad, totally bad, because this allows for an easy user enumeration. It's forced. You must formally ask for changing it. You cannot autonomously modify that. So if you know my surname, my name, and my birth year, I'm old, okay? You have my username, and you might try a brute force attack on this side. Brute force means that you already know the username and you try different passwords, but let's skip that part. Now this is my university life, okay? If I go to place like, let's try this. Okay, let's take this thing here. Let's go here. What's this? There's something there. This is a question mark, which typically separates the URL, the path of the resource, from other stuff, other data. It's called query string, okay? The strange thing about this is that if I take this thing here and I open a different browser, let's open, let's see. Now I opened an anonymous window from Chrome. I am connected through Firefox. So I'm changing browser. I put this stuff here. And okay, if you copy and paste that string and you open inside your smartphone that URL, you will become Simon Pietro Romano in the ministry portal. Okay, it's 5 years that I'm fighting against this crap. Okay, I told them that this is something that should not happen, just for you to know. And luckily enough, I am done with things that I had to do in terms of career at university. But if I had participated, let's figure out, let's go to the home. I think that last time I participated in this crap was 2016. The ASN, Scientific National Abilitazione, qualification, okay? You would see here my application. And if you were a competitor of mine, someone who was an associate professor and should become a full professor, and I was in a competition against you, you could become me and just say, I changed my mind. This is how I won. This is exactly what I did. This is exactly what I did. No, but really, this is serious stuff, okay? You have the entire life of a university professor that is there, okay? You did not have, I will show to you. First off, you go here, change password. You might change my password, okay? This button was not there, esci. You had no way for exiting from this website. Once you were in, you were there forever, okay? If you go to the OWASP website, they tell you that rule number 1 is that if I allow you to enter somewhere, I must allow you to exit from there. So after 3 months, I was interacting with the computer emergency response team of the public administration. We have one. I was telling them, look, you should act on that. They asked the Cineca consortium to act upon that. And in the end, they said, okay, now the button is there. Do you want to see how it works? This is Firefox. I exit. So I'm not logged anymore. I go to Chrome. I'm still there. Okay, so it's fake. Okay, there's a session that lasts for now, it's 1 hour. First, before my emails to the CERT of the public administration, it was really forever. Okay.
So if you know,
I asked a number of colleagues of mine, I mean, not people working, physics, who are not necessarily the ones who must look after this, but my cybersecurity colleagues all across Italy, they really didn't care. They did not realize. And they said, I simply close the tab and I'm done. And I told them, no, you're not done. You're still there.
At this point, I need to provide.
Please. We should remove this. I mean, it's public. It's public. I mean, I have discussed this a number of times. I'm still angry about this. This should never happen, but this happens. And this is not just with the public administration. It happens in a number of cases. Next year, if you want to invite me again, I will do an entire talk about how you can break into remote systems if you are allowed to do that, okay? And there are things that might really excite you and scare you, okay? But it's important to know that. Okay, so let's move to, I will be quicker now. This is the typical web application penetration testing cycle. Basically, as I was telling you, you should first off define the scope. I want to study the web portal of the public administration. This is my target, okay? I do a first phase that is called reconnaissance or footprinting, scanning, and enumeration. So I collect information, data, in order to study that target. And when I'm ready, I can decide that I start digging more into the details and look for vulnerabilities. And then for the vulnerabilities that I find, I can either create exploits. An exploit is some code that leverages the vulnerability, or if I am a good one, I just create a proof of concept, okay? But basically, the cycle is the same one. And typically, there are tools that help you do that, okay? Let's have a look, for example, at one such tool. Again, from the OWASP website, there is a beautiful instrument that is called ZAP, okay? ZAP is a proxy plus an automated penetration testing tool that you can use in order to carry out automated analysis about the vulnerabilities of a website. Okay, there are others. This is an open source one and a free one. There are others that you should pay for that contain more or less the same features. Okay, so here I'm doing a lightweight thing. I can do an automated scan, for example. I typically use Unina. Okay. Oh, it's down. Perhaps it's down now. It's great. It's not. That's definitely. I don't want to use other sites. So Unina website does have HTTPS, but you can access it also via standard HTTP. It should, it does not do that. Yeah, you can do that. I think we're not reaching that site either. Okay, but in general, if you want to try it yourself, you can download this from the OWASP website. It's a very interesting, I don't know if I did not save any. No, we won't go outside Unina, please, not now. I mean, this is not doing any harm, but it's creating a lot of traffic. I know. I know. So that's why I will never point my tool towards that. Okay. But really, I know that curiosity gets somehow stimulated, but you can use that. And as I always tell my students, please be very much careful when you use these tools. Because you see, this one is definitely a vulnerability assessment tool, but it attacks sites in the sense that it creates a number of requests and it analyzes the responses. I can tell you that if you use this, for example, against quote unquote UNINA, you would get tons of useful information. Once again, we are quite, let's say, open to a number of vulnerabilities, and the most possibly interesting thing that you would discover is that there are tons of PII, personally identifiable information, that leak from our site, okay? If you take docenti unina it, w page, who page, docenti unina it / my name, for example, now you will not get any data back just because I informed our technical staff that there were too many things that should not be there. Not in my case, because I know that that page is for public stuff that we want to share, but there were personally identifiable pieces of information, in some cases very delicate ones, that were leaking from that site. And the reason behind that is that, for example, if we do a scan in the department and then we ask the device to store the result of the scan to our website, it simply uploads it to my website and I then forget to remove it from there. And if it was something personal, it will stay there. And by using tools like this, you will find tons of information that should not be publicly available on the web, okay? There are things that you discover when you start looking at things. And I think that at the data science class, this is something that you already know. If you look into data, you discover stuff. If you don't look into data, you are happy, but you are simply ignoring things, okay? So one of my research areas is the automation of all the things that I was telling you, okay? So I give for granted that I have some knowledge as of how you can find vulnerabilities, and I would like to let some software do my job on my behalf in a way that is as intelligent as possible. Because, you know, there are lots of tools who do this, which do this, but they typically do this with a brute force attack. Brute force means that they have a huge list of things that they might try to send. Let's take the cross-site scripting example. What do you think a list might look like? It would contain things like script, alert, something, okay? Or close this tag and do this other thing. So if you have a huge list, a dictionary with all these things, you can simply try and use all of these strings as inputs that you send to the web server, and you inspect the result. What do you think that I mean by inspect the result?
If there is a name, if there is a value, they will find it out.
Okay, it's in our case, the very first check is simpler than that, because what did I ask you to notice with the website that we were attacking is that the string that I was providing was then bounced back to me. So the very first check that you should do is at least part of my input reflected in the output? So the response that I get back, does it contain at least part of the input that I have sent? And there are many tools which simply rely on that. They simply state, okay, there was my input inside the output, so it is vulnerable. And this is not true. This typically might be true if the reflection happens in a context that is an executable one. So if the thing that you are bouncing back can be executed by the browser, but what if I put the result inside the div field, as I was telling you? In that case, it would be bouncing back, but it would make no harm. So you should check first, is it bouncing back? Yes. Is it a vulnerability? I don't know. What else should you check? That definitely the thing that you have received back can be executed from within a browser. Okay, and there are automated tools that allow you to do that. If you look at the tool that we were trying to use, you see this thing here, Firefox Headless. What is Firefox Headless? What do you think? It's a Firefox with no head. What's the head of a browser? The user interface. Okay, I can use Firefox with no user interface. This might look crazy. For me, it is fundamental. I can use the engine of Firefox without showing the results inside the nice graphical user interface. I don't care about the graphical user interface. I care about the fact that if I receive something back and I call into action Firefox with no head, and I ask, hey, Firefox, tell me, does this code execute? And it tells me yes. For me, that's a yes. If I re-put the head on top of Firefox, this becomes something that gets executed and that creates harm if the script is a harmful one. Okay, so all of these tools use things like this for doing automated interactions with the remote web server without the need for also showing the user interface. The user interface is just the tip of the iceberg. It's just what we must show to the end user. But the rest is an engine that works behind the scenes. And that one is the heart of my browser. Okay. And yeah, and there are frameworks that you can use as programmers that allow you to make the web work on its own, all alone. Selenium, just browse for that. Selenium is a nice framework that allows you to choose Chrome, Firefox, Edge, or others. And you can write Python code or JavaScript code or other code that typically somehow orchestrates the heart of a browser in order to ask it to do the same things that it would do when interacting with a human being, but without the need for having the human being really interact with the engine. Okay, so you can program all that. And here it is using this for a specific part of the assessment. That is when you have asynchronous interactions with the server. You know that there are pages that are called single page applications that we use when you are in Facebook, in Twitter, or in your preferred social network. You have one page, okay? But many things happen. If someone is writing a message to you, you will see the message appear in your page. Okay, if you have advertisements, you will see the ad appear in your page. You will see things happen. If you are on Google Maps, you will see that there are cursors and things that move. This is a single page application. So this basically is an integrated application that behind the scenes carries out interaction with remote sites. In order to mimic this part, you need a headless browser that basically sends asynchronous HTTP requests, collects responses, and analyzes them. Question? No. Please. Let's change subject.
Tell us about, I mean, I imagine that cybersecurity is a very, very fast growing and evolving field of science due to the fact that cybersecurity is used from, IoT to steal data, nations going war against each other. So what do you do? How is it? How do you stay on top of the state of the art? Do you select a very narrow field in which you...
This is a great question. What do I do in my life? Yeah. Yeah. No, but I mean, it's an interesting question that any researcher would love to receive. Part of the things that I do, you will see in the remaining 10 minutes, okay? In this, first off, I am a networking guy. So my soul is in the internet. So I'm interested in network security. This is a first categorization. I do love cryptography, for example, but I'm not good at that. I'm a good user of cryptography. I would never come out with a brand new cryptography scheme with a nice elliptic curve. I had to study all of them, but I don't like them. I have to admit, okay? So I'm not a mathematician. I must use mathematics in my studies everywhere, but I'm not providing any original contribution there, okay? If I can dare to say that I provide a few original contributions, I do this either in the real-time field or in the security field, and I try and apply nice ideas to the network security environment, which means, for example, that in the last years, I've been studying quite a lot these things, automating the procedures for discovering vulnerabilities. And you will see that I've had, obviously, to apply machine learning, deep learning, and also there I have applied results that other people have created, but I hope I have applied them in a creative way in order to solve things that had not been solved before. One other part is about devising architectures that are robust ones that allow people to rely more on the infrastructures that they use. So we leverage virtualization in scenarios where you must look after security since the outset, the design phases. And one specific vertical field of study for me is critical infrastructures. I'm personally very much interested in protecting critical infrastructures. What is a critical infrastructure? A pipeline, okay? A grid, something that is important for our everyday life and that currently is not just an industrial system. It used to be just an industrial system, but now it is connected to the internet. We talk about IT, information technology, / OT, operational technology, coexistence. So what happens if I have a dam, una diga, that is controlled remotely through sensors that provide information about the current level of the water inside the dam, the pressure, the pollution, and so on and so forth, but that can be controlled remotely from a station that gets connected to it in some way via the internet. I want to protect that. It's not just a movie. The fact is that in our real lives, these infrastructures are there, and I can tell you, unfortunately, that these infrastructures are vulnerable, okay? What if I have a gas pipeline that is a vulnerable one, okay? And which crosses our country from east to west? It's a problem. Okay, it can be remotely controlled, it can be hacked in some way, so it's a tough issue. And exactly. Okay, so these are the main fields of interest. But thanks for the question. So basically, let's come exactly to that. I think that I can skip this part. I think you know what an agent is all about. It tries and carry out an action. It gets either a reward or a penalty, depending on how much it is getting closer to an optimal, let's say, optimal solution. In my case, the optimal solution is I found the vulnerability, okay? Cross-site scripting, I think now it's quite clear. I might craft a phishing email. You are instructed as to click on a link, and then bad things happen. And you should also now have a bit of an idea of things that I'm showing here, for example. The example that I have here starts from zero knowledge and tries to construct the end result, in my case, that is an input string that is working as an exploit, okay? So an input string that, if provided to the web server, allows for both reflection and execution, okay? So you see that, for example, here, if I start from zero knowledge and I say, okay, let's try and send alert 1. So an alert, a function. Let's see what happens, okay? If I see that the string is bounced back, so it comes back to me, but it is not executed, I already can say there's something good, that is the fact that it has been bounced back to me. But now I should properly tune the string that I'm sending in order to allow it to become a reliable and working piece of code. Okay, So I can add something, and here you see pre-context. So in my case, the context is the context of execution, which means that something can be executed just if it is in the right context. Okay, the right context is, for example, directly inside the HTML page. Okay, without causing any errors to be raised by the parser of the page itself. So for example, here as pre-context, I'm using something that is, I'm closing a text area because I realized that I was being reflected inside the text area. What happens if I am reflected inside the text area? That my code gets not executed because it is simply printed down inside the text area. So what I do is I close the text area and I try with the string again. Okay, I add the script tag, the opening script tag, and I see that there is an error. So I decide that, okay, I have closed the context. Now I put script alert of 1, I close script. And if it is okay, I use the post context, that is, I close the HTML tag that was the envelope of the stuff that I'm writing in order to make the browser happy. Okay, so you see this sequence of actions is like that. No observation available. I start with the payload, the potential attack string. Okay, I send it. I see that it is reflected inside the text area tag. So it has been sanitized in some way. Okay, so I send again by closing the text area, which means I'm closing that context and my stuff goes inside the new context. And perhaps the new context is an executable one, if I'm lucky. Okay, so here I see that it is reflected inside HTML. So I add the script tag here. Okay, so I had closed the context, put the script and your payload. I see that the tag was not closed, so there is an error. I close the tag and I'm done. So if I were a professional, I would follow exactly that path. Okay, I would start with a payload. I see what happens. Is it reflected? Yes. Where is it reflected? Inside the text area. Let's close the text area. Let's try again. Is it reflected in a runnable, executable context? Yes. Let's put script. Is there an error back? Yes. Why? Because the script has not been closed. So that's it. And basically what we devised is an environment that is associated with the state action space where you have pre-context. That is all the things you should do before starting the injection of the payload, the context, what you do before the exploit, okay, which might be empty, obviously. Then you have the exploit code. In my case, a simple script, might be a more complex one. And then I have the post context. So basically, we started with this and we designed an environment, but we wanted to understand whether or not we were capable of keeping the same level of performance of other tools that are available out there, which typically use a brute forcing approach. Okay, so we started with asking ourselves something that people like you might answer. Do we have a data set? Okay, and the reason we asked ourselves is that if you want to carry out a performance assessment campaign, you do need a good set of data, and the data set was not available. Okay, there was something that was obsolete that is called WAVSEP, Web Application Vulnerability Scanner Evaluation Project, once again from the OWASP community. First off, we worked on making it become more up to date. So one thesis project was just about that. One guy was good at doing attacks who populated the data set with more up-to-date attacks, okay? And we made this available for the open source community, so it's publicly available. And it's been a nice first contribution. Once we had the data set, we started with the first iteration. This is not a 100% automated cycle. This has the human in the loop, okay? So we started by somehow training our environment by saying, let's try a string that for us is the input we want to test, and let's see what is the output. Then let's have a human inspect the output and decide what is the next step to undertake, okay? We needed that because we needed some intelligence in the way we choose the next string among the available set of strings based on the feedback that we have received when we have received the output from the last string that we've tried, okay? We were not able to automate that part. We needed still a human brain there, okay? But we automated the right-hand part of this slide, as you see, okay? A second iteration, we decided to start automating also the observations part. So we worked on a module. It's a complex one, but I will skip the details now. A module that is capable of observing the responses and providing hints as of what might be the next good move to make, okay? So in the end, we took the two things and we arrived at a fully fledged environment where the observer module has been integrated with the part that was on the right-hand side that I was discussing in the previous slide. And we studied this in a way that is as formal as possible by leveraging the Gene OpenAI framework. So we found it was quite flexible, and we were able to bend it towards our needs. I know that it is a bit cumbersome in some cases, but we had already some experience with it, and that's why we leveraged it. What alternatives would you have in mind? Because we evaluated a few of them. I see. Verge, I promise. 10 minutes. No, it's okay. No, just for you to know, there are a few key performance indicators that we typically use when we work with security. I think you can, by intuition, understand most of them, obviously, the true positives, the false negatives, and so on and so forth. So basically here I'm putting a sort of comparative benchmark. Our tool has been called Suggester, and we have compared it with the number of other tools. There are a few of them that are proprietary solutions that you should pay for, others that are open source. And we typically use at least these two measures, precision and recall. And as you can see, our tool performs better than most of the other ones. It is comparable, especially to this one, XSS Map, which is a very nice one, even though it has a higher recall score when compared to XSS Map. And in terms of precision, the two ones that I was mentioning are the top performing ones. Please just keep in mind that we were able to have a high true positives rate because we remove the false positives. A false positive is when you say that there is an intrusion. In our case, there is a vulnerability to cross-site scripting, and indeed the vulnerability is not there. So it is something that you thought is there, but is a false belief. Okay, we remove false positives by leveraging the headless browser thing. So when we see the reflection, we don't stop there. We see there's a reflection, but does this work? Okay, and this is not done by most of the other tools. Okay, so now there's a nice graph that I typically like to show. This might look complicated, but it is not. This is called Uden index. You see here you have false positive, here you have true positive. So basically the line that you see here is what we call the line that we would have if we were to just, you know, launch a coin and see what is the result. And so it's just guessing, okay? So if you are here, you are really bad. You are worse than guessing. If you are in this quadrant, you are better than guessing. And obviously you should be as close as possible to 0 here, because this is false positive, and as close as possible to 100% here, because this is the true positive rate. Okay, so basically we are performing quite well. We can improve in terms of discovering more things that escape our analysis. But please keep in mind that there will always be things that are escaping your analysis, at least in this field, because there's no limit to creativity, I have to say, okay? Even if you take an expert computer professional, they might not find all of the vulnerabilities that are there, but as many of them as they find, their performance is obviously better. One nice thing, and I'm almost done, is this one. We are not using any brute forcing approach. We are trying to just send the minimum set of requests that is needed in order to cover what, in our view, is the entire space of actions. Okay?
Instead of selecting actions on dictionary, you try generate them something like
An adversarial gun.
no, something like yes, but generate the values something like a transformer trained to write Java code, and then you use the Java code generated, so you will increase it on the state.
These are great questions, and we are currently investigating exactly that approach. So automatically creating pieces of code that can work and that you had not even thought about.
Exactly.
We
should use them as an action.
We're working on this. It's our current work is one of the directions of our current work is exactly that. And we were also trying, but we have no results on that. We are interested in exploring a generative adversarial network approach to the generation of payloads that we can try to use. No, it's true, and this is something that we want to explore much more in depth because I think it can provide very interesting results.
We have white sun. I think you are fully aware of that. So in white sun, I can go for whatever he has asked. I can go for one by one line code, the HTML code. So I'll map with one IP. He's using some particular IP.
Yeah.
I'll filter it.
Yeah.
Then I'll see one by one call. Whatever he's calling.
Yeah, that's it.
That's a solution, right?
That's a solution. That's one of the things that we can do.
Yeah.
Definitely. No, you touched upon two of the points that are under investigation right now in my group. Interesting. Yeah, definitely. Thank you. So, okay, basically, one more, let's say, issue that we have with this kind of systems is that the problem has a categorical nature. So it can very quickly explode in your hands. Okay, so you cannot necessarily keep on using exactly the same approach as I was discussing if you want to make it scale. Okay, so one of the things that we are experimenting with is the use of models that capture the real dynamics of the system. So you don't start with the, let's say, zero knowledge approach. You try and model the most important dynamics of the system, and then starting from there, you apply RL-based approaches, which is, so like a kind of a mixed approach where you can try and take the best out of the two words, the, let's say, legacy, let me call this legacy, but without attaching any bad meaning to that, and the brand new approaches associated with reinforcement learning. So this is something that we are experimenting with. Just to provide you with a couple more pointers. We're also working on creating a sort of knowledge base of what an attacker can do. It might look strange, but there are a number of models that already do exist that try and model what happened if you received an attack. So a very formal definition of all of the things that you experienced while getting the attack. There are no official models that try and mimic the behavior of the attacker. So a goal-driven knowledge base where I start from my final objective that is attacking you, and I find a path inside the knowledge base that tells me start from here, go there, move there, and this can be done in an optimized way. So we've done some research also here. We created a sort of taxonomy that starts with the idea of having the hacking goal and then moves across a number of intermediate steps that bring you in the end to the final target, that is really getting your system in the target system in your hands with what we call the full ownage of the system. And we're still working on this. We're also working on a different kind of system that just tries and recommends actions to undertake. So starting with the knowledge base that I was describing, you ask the system to provide you with hints as of what is the best next action to undertake. If your goal is that, and you have already done this, and this other action, it moves along that knowledge base. It provides you with hints. It collects back the feedbacks as of where those actions effective or not, and then it populates again the knowledge base. You know that with these kind of knowledge bases, you do not have the so-called closed word approach, where you have put all of your knowledge inside the system and the system gets not enriched with further information. This is the open word assumption, where you say, I have a knowledge base, but I can make inference on that, and I can enrich it with my experience. So this is one more thing. And the last thing is, again, about data sets. We have created a sort of automated collector of penetration testing sessions. Just figure out, I am working, I'm doing my penetration testing session, but I record all of the actions that I take in an automated fashion. This can be done quite easily. You can use a proxy component. That means something that acts on your behalf. So all of the actions that you do are indeed carried out by proxy component. If the proxy also records all of your actions and also timestamps them, then you can really play them out. So you can replay those sessions. And we have used this approach in order to populate a data set that we want to use in order to have more data on which to train our solutions. And with this, I think I took too much of your attention. I'm basically done. The idea is to automate offensive security by trying to be as intelligent as possible. And obviously, always keeping in mind that intelligence is a human thing, okay? It's not just an artificial thing. So we need what Professor Longo obviously calls the expert of the domain. If you do not know anything about cybersecurity, you cannot contribute to that. But if you know at least something about cybersecurity, with your knowledge about the technologies that can be used in order to improve the way we automate things in our life, this can become a beautiful mix of competencies, and this can bring to interesting results. So if you have questions, I will be glad to take them.